Okay, physics and friction. So let me describe for you the two flavors of friction that we use in physics and give you some examples of how these are used and what's important about them. So two flavors are static and kinetic. So when something is stationary, we'll describe that as statics, and we can have a force of friction, and we'll give it a little S for this. And we calculate this by saying this is some coefficient of friction, static friction, times the normal force. Right? So you want to be careful of that. If you push a little bit on a box, and it doesn't go anywhere, it's pushing back just a little bit. So the force of friction can be very small, and you can push some more and it still won't go anywhere. So a force of friction that's static can be up to a certain maximum. And sometimes we say the force of friction static max. So it is a common way of phrasing it. So this is the most it can be, and it can be less than that. So be careful with that. Kinetic friction, however, is always the same. So once something is in motion, the amount of friction that comes from that is always going to be equal to the coefficient of kinetic friction times the normal force. So notice that this is a simple formula, right? So all you need to know is the normal force and the coefficient, and you can figure it out. And the coefficient is something that describes the surface area, the surface between those two. So if you have something that's really rough, then you have a higher coefficient of friction, and we'll have something that's smoother, like ice, will have a very low coefficient of friction. So a coefficient is going to be something that is going to be less than 1, right? So I can't really have more than normal force if my friction is more than normal force, right? I'm just lifting it. So that's not doing anything. Oftentimes we'll put absolute values around these. So you have to decide which direction. So it's not always obvious. So the friction is going to be going counter to the direction of motion. So you can't really tell a lot of times. So just by looking at force from forces. So if you have something that's moving in one direction, has force in the opposite direction, that you can't tell from forces. So be careful about the direction of motion. So let's look at a couple of examples. So here, this is the traditional box that's sliding across the floor. So notice this is described as kinetic friction. So this is already in motion. And it doesn't matter the velocity that we have, that the amount of kinetic friction is always going to be the same. So it's kind of a curious thing and different from drag. So notice what's going to happen though. So what I'm going to do is I'm going to change the angle here. So if we lift at an angle that's higher, notice that my normal force becomes less because part of that angle that I'm lifting at, some of that force that I'm using to pull is also lifting up, and that's decreasing the normal force. So my coefficient, my friction goes down. So the coefficient is the same, but now the normal force is less, and so the amount of friction is going to be less. So normal force and friction are things that are very variable, and something like the weight or the mass of this thing is not going to change. So we want to be careful about that. So even though I'm applying the same force, I can get different speeds. In fact, it's a little bit faster not to pull it straight, just a little bit faster to pull it up at an angle, in this case about 20 degrees, to make it go a little bit faster. We'll make this a little bit more complex. So one of the things we like to do is put things on ramps. So ramps are classic examples. So let me talk through this example of a box on a ramp. So some important things to notice. So first of all, notice that where the angle is. So the angle of my ramp also shows up as this angle between what is opposite my normal force and gravity. And so that force of gravity and that perpendicular line, that's going to match the same angle. So convince yourself that that's true. You can draw some triangles and figure it out that way, or you can trust me. So this is stationary. So notice that I have a static force of friction, right? And this could be very small, right? So if my ramp angle is very small, the amount of static friction required to hold it there would be very small. And as I increase my ramp angle, eventually it'll get to the point where I have reached that maximum static friction. And then once I go past that, my box is going to start sliding. So let's see if I can change the mass of this. And as I increase the mass of this, no, that's not going to work on this one. Well, let's try, can I increase the angle? Where's the angle? Yeah, let me try increasing the angle. All right, increase the angle. Is it going to go to, no, it's not going to do it. Oh well. So if you could, if this was a real life, you should be able to increase the angle of this. And at some point that box would start sliding. So you would reach the maximum coefficient of friction, but maximum force of friction. So notice what happens though, as I go to a shallow angle, that static friction changes. That becomes less, right? I'm not changing the mass of the box. I'm not changing anything. So my normal force becomes less as I go to a larger angle, and my static friction becomes more to hold it in place, right? And the way I think about this, right? So I'm going to break gravity into components. So I can break gravity into components. So one is going to be equal and opposite to the normal force, right? So it's in equilibrium vertically off the ramp, so it's not accelerating in any direction. But horizontally along the angle of the ramp, that I'll have that some fraction of gravity pulling it down the ramp and some static force pulling it up the ramp in this case. So notice that once it starts sliding though, so if I give it some initial velocity, I don't know, 2. So once I start giving it some velocity now, this changes to kinetic friction. Right? So once it starts sliding, static friction is out the window, and now I have kinetic friction. And you can see just from the length of these arrows that fraction of gravity pulling it down the ramp is greater than that kinetic friction pulling it back up the ramp. And this has to always be the case, right? So so my kinetic friction is going up the ramp in the opposite direction of motion. So here's a curious thing, right? So I can change the velocity to -2. So what does that mean? So that means that I've pushed it up the hill. So I've given it a velocity going up the hill, right? So I've pushed it and it's going uphill. So notice that now my kinetic friction is the opposite direction. It's opposing motion. It's opposing velocity. So now my kinetic friction is in the same direction as that component of gravity pulling down the hill. So what's going to happen? Well, it's going to slow down even faster. Right? So it's going to slow down to 0, and then it'll come to a stop, and then it'll change motion directions. So when the velocity changes directions, my kinetic friction will change directions as well. So the acceleration that it experiences up the hill with friction is going to be different than acceleration experiences down the hill with friction. So think about this. Going up the hill, that's going to have that fraction of gravity and the kinetic friction working against it. So I'll add those two forces together, and those are working against it to slow it down. And coming down the hill, I have friction going slower, slowing it down, and that same fraction of gravity pulling it down the hill. So those forces will work against each other, and the net force acting on it is going to be smaller, and the acceleration, the magnitude of acceleration, will therefore be smaller as well. So so be careful on ramps. So friction changes direction, so it's always opposing motion. You have to figure out the motion direction to make sense out of it. So so ramps are really handy things, and it's a handy way we'll use to measure the coefficient of kinetic friction and the coefficient of static friction using a ramp by changing the angles, and that's one of the labs that we'll get into. So, anyway, hope that helps. We'll talk to you soon. Bye.